So here we're going to talk about optimizing your SQL Server performance in a virtual environment. When I'm talking about this, today's content is solely focused on ESXi and vSphere and that kind of stuff. I'm not going to talk much about SQL Server. So the DBA is hoping to get some tips and tricks about SQL Server and those kind of things. This is probably not going to have much in there for you. But it's also have a lot of things to understand to make sure your database is working properly, that your infrastructure is set up properly. So these are some generic slides that you're going to see a lot of the performance, decks out there, talking about the different virtualization tracks we have out there for making your large VMs work properly. Here's a slide from market research regarding how many people have already virtualized their SQL Server and or other technologies. You can see that 87 or 81% of basically people have already virtualized their SQL servers. So if you're not virtual in production, you're the outlier now. It's time to get it done. And where can you learn more? So VMware has a lot of great information on things like this. I'm not a VMware employee, so this is provided by them and areas where they find their information. So who am I? I'm Sean Myers. That's me without a beard. This is me with a goatee. Next time you see me, I might have a full beard. It might be different. I change it up. So I'm the practice lead at for SQL Server at House of Brick. I've been working with SQL Server since 1996. Actually, on the flight out here, I was talking to a guy, and I realized that I've now been playing with databases for 40 years. My dad was a programmer. Our first computer we got in 1977, and I was born one. And I was using DBase 2 to create a database to track my mom's Hummel collection. So I've been doing databases now for 40 full years. And I'm not really that old either. So House of Brick, what does House of Brick do? So we are a small consulting firm. We focus on Oracle and SQL Server performance tuning, replatforming, moving your database from Oracle to SQL Server, which is my favorite because SQL Server is better than Oracle. But we're not going to talk about that too much today. We also work on your HADR solutions and licensing reviews. And of course, virtualization. Overview. So virtualization, obviously it's now a shared environment. So you have the issue of, do I make it share everything equally, or do I make it go fast for one? Because sometimes when you have the large SQL Server, you want it to go faster than everything else. And we're going to talk about where things go back and forth on that. Also, memory and storage are your keys. 80% of the issues I see out in the world are related to one of two things, your storage or your memory. And as storage is getting faster, it's getting less and less and thought easier to do some of this stuff. Your CPU and network are still important, but they're not as critical. I don't tend to find as many CPU issues, and rarely I see a network issue. So agenda, we're going to basically walk through storage, through memory, through CPU. You can read this. All right. In storage, we're going to go through multiple sections of storage. The host level. The things I care about, paths. You need to have as many paths as possible to your storage, and have it set up and configured properly. Using the Lua and your PSPs. If you don't have a plugin from your storage vendor, making sure round robin set to 1 on all flash arrays is a good advice, but understand that kind of stuff. When you're using iSCSI or NFS, make sure, when you're using iSCSI or NFS, make sure your network is robust. That's where you run into problems. Queues. At the end of the day, a VSXi host is just a collection of queues. It just does, it's a section of lines. It's for resource sharing and how you do it. These KBs from VMware, so I'm covering a lot of information on this deck. I put a lot of KBs so you can go find the information and read more in detail about it. Instead of trying to do in-depth on certain of these things, I can spend 5 or 10 minutes talking about each one of those KBs. You guys can read the KB and go learn it, instead of me trying to I want to cover a lot more information. The biggest ones here, so we're going to walk through all these real quick though. The Windows registry, which is your storage queue depth. So basically this is a pair of virtual controller and how you adjust the queue depth on that, so you can have more of those. The defaults are kind of small. The queue depth for the HBA, the defaults on those are ridiculously small, and you need to be updating on any in EXI's host in general in my mind, but anything running a hosted SQL server should definitely have it set. The defaults for some are 32, some are 64, it varies by your HBA. The outstanding disk requests, also kind of small. But how high you make it, you shouldn't just set it to the maximum, because the maximum causes some other issues sometimes. So you need to tune it and look at it. And we're going to go through the performance counters to look at later on so you can understand what it is. Also, questions. I like questions as they come up. If I'm running short in time, I will table them until later. So if you have questions, please just raise your hand and I'll call on you. And adaptive queue throttling. The good thing about this one is if your storage system is backing up, having this flag set properly, the ESXi host will slow down its request to the storage system, so it's not going to oversaturate your storage system. That one's also very key to enable. It's off by default. All right, at the VM level, paravirtual controller. KB there is basically how to go convert it. You should be using the paravirtual controller for your storage. Your C drives, they definitely can still be on the LSI logic because the driver issue, and especially if anyone's doing it for a long time, you've had that problem where you've had to use the flip files and inject drivers in. It does work now in 2012 and beyond just fine. But paravirtual for all your data and log drives, definitely. It is at least 10% faster, if not more, and it has less CPU impact. Multiple controllers, and possibly multiple data stores. You need to have multiple, as you put more and more I/O through it, you'll start to see latency increase. As your latency increases, it's time to add multiple controllers. For all SQL servers to start off with, I start with at least 2, and then I go to 4, depends on if I need to, by those numbers. Multiple data stores. As I see latency creep up, I also tend to see basically a threshold number at 400 megabytes per second of throughput. It's a guideline. This is not a metric. This is just kind of what I've observed over the years. After 400 megabytes per second throughput onto a single data store, I see my latency issues. Now, so that's a good way for me to go, hey, it's time to split. I need to have multiple data stores. I have SQL servers I manage that have 12 to 16 data stores attached to just that one. And of course, you all know the limit for the cluster in VMware is still 256. So if you have a lot of SQL servers and they're really large, really high performant, you run out of data stores quickly and you end up with small clusters like 6 to 8 hosts in the cluster because you have no more room for storage. But you need the performance, so you're going to do it this way. Your disk type, thick, thin, eager, zero thick. I used to care about it. 4.1, it was very, very critical. If I want my performance to run properly, I need to have it. The storage vendors have done an amazing job of making my storage so much better, and VMware has done a better job of the locking mechanism that does the growth process. I really don't care about it as much anymore, and if someone wants to argue with me, I don't care. I just say, fine, do it the way you want to do it. It doesn't really matter that much. If you're still running on version 4, then it does matter, but you shouldn't be on 4 anymore. AFAs also minimize the impact, and most AFAs nowadays, and AFAs on all flash array, by the way, and AFAs nowadays will only offer thin, because the growth process is so much faster. And of course, tools and hardware version. Keeping those in sync and making sure you update your hardware version and your tools using the latest and greatest. As VMware has new versions come out, they actually have better drivers, better firmware basically, that based upon that. So having those means you have the latest and greatest. It means your things will run the fastest. So in the guest, from the operating system perspective, spread it out. Even though all your drives a lot of times are now in one storage system, it doesn't, people say it doesn't matter. You still want to separate out your workloads because it makes troubleshooting from a database perspective much, much easier. The DBAs are still going to want to have multiple drives, and they need multiple drives. And it makes their troubleshooting process so much simpler when they try to pinpoint, where their hotspots are. So when you use ingest, what you can do with SQL Server in VMware, and a lot of people don't think about that, but there's a lot of great advantages of using ingest for performance reasons, especially now with in 6.5 we've got RDMA, or PV, paravirtual RDMA. Because RDMA, far and away, is the fastest storage presentation you can do to a database server. If you're still doing, if you're trying to do a failover cluster instance, you still need an RDM-P. And if you're using RDM-Ps, that KB down there, that is for perennial reserved RDMs. What that means is when you reboot your host, it takes a while because the RDM is now locked by a different host. VMware will sit there and spin and spin and spin, waiting to get access to query it to find information. If it doesn't find it, it times out eventually. It can take up to half an hour to reboot a host. That KB, follow that instructions real quick, you flip it over, and then basically now your reboot of that host doesn't have an issue anymore. And before you ever do anything with a failover cluster instance or an availability group on VMware, that KB there, read that, follow it. There's a different one for 5.0, 5.5, and 6.0. No, 5.5, 6.0, and 6.5. They go through all different support matrix. When you read that KB, you're going to find it is the most horrifically written KB you'll ever find. It is confusing. Sometimes, if I have more time, I go through, open up one of the copies of them, and then just walk through what's all involved in it. There are many bullet points. There are a lot of asterisks. There's a lot of gotchas of, oh, you can do this. Under this, 5 different conditions have to be met first. So make sure you read that and understand it. There's an awful lot in that KB. And I know many SQL Server DBAs, myself, David Klee, Danny Cherry, Alan Hurt, we've all worked with VMware on trying to cleaning that up. It is still a horrific KB. But it still is the only true source of information. All right, so at the storage layer, this is basically from what I expect when I talk to my storage admins. Hey, I need to know what's going on. So follow the vendor's rules on the storage. The fun part is, I talked to a lot of storage vendors. They'll have a best practice guide for VMware and a best practice guide for SQL Server. They will contradict themselves. So which one do you follow? In most cases, I'm going to go with the VMware version of it with some tweaks. But push back on your VARs or your storage vendors to get you a SQL Server on VMware best practices guide, and a couple of them have it. If they don't, beat up your storage vendors. They deserve it sometimes. Disk pools. Disk pools still matter. I know a lot of storage vendors go, no, 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 no. The problem is, even in AFAs, it still matters. In the spinning Rust world, when you have a VMax and you stack 1,200 drives all in one giant disk pool, your performance and your throughput is phenomenal. Problem is, though, my latency will creep up. And SQL Server is so latency sensitive, it causes problems. EMC has one of their guides that actually says for them, their ideal size for SQL Server is a disk pool no more than 144. I've seen 200 work just fine. Anything above 200, I start seeing latency creep up from a SQL Server perspective. AFAs, I don't have a guideline. I have seen people who have basically VMaxes with all flash in them, and they create the 1,200 drives in one massive data storage or one file group. I still have our disk pool, and I still find latency issues. It's not as bad because the storage is still phenomenally fast, but it's still there. Cheaper to put everything on AFA. One thing I discuss with people a lot is if you have multiple dev environments, instead of having a copy of production and a copy, copy of production in Flash and a copy of Dev 1, Dev 2, test, QA, patching, all those kind of stuff, and all those are on spinning disks. With the advantages now I see with the dedupe and compression from your storage vendors, putting it all in Flash will actually use a whole lot less space, and in most cases now, because Flash is so much cheaper, it's actually cheaper to run it this way. The prices have come down. And as Flash gets cheaper and cheaper, I've had a customer, they've got a 12 terabyte data warehouse. They had 4 copies of dev and 1 production. The production was on Extreme IO at the time, and it was using with compression around about 2.4 gigabytes or terabytes of space on that. We moved all the dev there because of the Delta files. Now we have 2.8 terabytes of data total for these 60 terabytes of old space. That's a lot cheaper and a lot easier to manage that. The thing you got to worry about that, of course, is developers don't always do a good job of snapshot management. When you're having snapshots for dev on there, they will grow over time. You need to have rules or an SLA with them. They can't keep it over X time. I tend to see about every 30 days, you'll have about 10 to 15% of rate of data change on most databases in a development environment. So your snapshot should probably not exceed more than 30 days. SQL Server encryption. There's a lot more SQL Server encryption going on at the database level now. And you're going to see more and more of that. The latest version had a new feature called Always Encrypted, which does some row-level encryption process. And there's a lot more TDE, and then there's also just whole row and data encryption stuff. All those things cause storage issues. So again, most of your flash arrays now have TDE kind of encryption enabled. If not, you can buy that feature. But when you start encrypting your databases and encrypting your backups, your dedupes and compression in your storage layer do not work anymore, or not as efficient. So you be very careful with that. All points in the storage path are very important. Example is, customer had a physical box. It had 4 2 gig HBAs in it, giving us 8 gigabyte throughput. They virtualized it, put it in a host that had 2 8 gig HBAs. Performance is horrible. Everyone's blaming virtualization. Virtualization is bad, blah, blah, blah. You can't do this. We got to go back. I'm like, let's troubleshoot this. When you go into the storage layer, yep, it's running at half the speed it used to. We have the charts and what's going on? And they're still trying to push back, roll back. I'm like, let's walk through this. And we walked through the storage path from the host, through the switches, to the storage layer, or the storage presentation. And what we found, of course, is they use the same switch. So they plugged the 8 gig fiber channels into a 2 gig fiber channel switch. And they couldn't figure out why he was running slower. It was one of those pause, blink, think. Oh, they figured it out finally. So again, making sure you actually understand the entire storage path. And storage caching. I see a lot of interesting issues because people don't truly understand the storage caching layers. Because what happens is when I'm using a lot of intensity, a lot of high IOs, and I blow through the cache, what happens to my performance? And making sure that the cache is balanced properly from a read-write perspective. And each storage vendor has different rules and different things. And it comes down to working with the storage vendor on this is where you're going to use the SQL Server best practices for storage cache, not the VMware best practices. Sizing. So most DBAs do a really bad job of sizing of databases. First of all, there's they've had habits of, well, my data grows at 20, 25% per year, so I have a new database that's going to be 100 gigs, so I'm going to ask for 500 gig. Because, well, it was a pain in the butt to take the outage and add things to the LUNs. And they still are in that mindset. Also, capacity is not the issue database administrators need to worry about. It is performance. And you run out of performance way before you run out of capacity in most cases. And storage admins have this bad habit of, well, we've got 5 terabytes of disk not being used. No, we're using every bit of the I/O on those things. You put another VM on it, it's going to slow down my database lookups. So again, think of your storage from a performance, not capacity perspective. So when you're looking at this, the DBA, you need to work with them on providing them storage charts, how much they're using today, because most of these workloads already exist. If they don't exist, then you're kind of taking a swag and just figuring it out. But helping them understand how much I/O they're really driving, how many IOPS or throughput. I hate using the term IOPS because every storage vendor gives me a different version of what they call IOPS. And like SQL Server, most of SQL Server writes and reads are in 64K blocks, so I want to talk 64K IOPS, they want to talk 4K or 8K IOPS, depending upon the vendor, and all that stuff. So I tend to talk in throughput more often than not, and then throughput and latency. So again, the next thing is perfmon. Perfmon has great stats for helping capture that data and making sure the perfmon data matches what the storage layer is looking at. Also, the DBA always been asking for RAID 10. They've been told since college that you got to have your logs on RAID 10. With the all-flash arrays nowadays, it doesn't matter anymore. So you need to convince them they have to update their skill sets as well to stop asking for things that don't really matter anymore. But as long as you can do it by SLA. And SLA, I refer to a lot of cases as going to be performance-based SLAs. Is my application going to meet the criteria? If I have 10,000 users running 10,000 concurrent connections, can my storage system handle that? That's where we care about the performance SLA. We don't care about it as much. It's still important from an SLA perspective on your RPOs, RTOs kind of stuff, but your database systems need to have a performance one as well. And the DBA actually needs to work with the app owners to figure that out. What is performance? What is the proper performance for this? So storage counters. These are when we walk through the storage counters, you look at the ones I care about, the ones I play the most in, first of all. If you have not gotten Frank Dendeman's book on the host resources deep dive, I highly recommend it. Anybody who wants to go deep, I mean way deep, this is the best book I've read in at least the last 5 years. And that includes even some of the SQL Server deep dive books. It's an amazing book for defining this. So latency is my biggest thing I look for in my storage layer. So I'm using ESX top, the K-AVG, D-AVG, and the G-AVG ones that I looked at the most. So the kernel basically means it's VMware-wise. The device driver is the other one, and the other one's combined. Queues, go look at your queues. Am my queue depth set right or not? Am I actually using it properly? So again, how I said some of those queues are small, but not setting them to maximum is not always the right answer. You actually have to go into ESX top and go look at things and see what you're using, what your current utilization is. Also, I see a lot of people writing down, if you want to copy this deck, just give me your business card, write 1984 on it. That's the session ID, and I'll make sure I will send it to you because I have multiple sessions and I don't want to confuse which deck is which. So here's some samples. I tried to do a demo, but I gave up on trying to force failures or force things to go bad. I just got some screenshots here. So this is in milliseconds. 46 milliseconds for storage latency, bad number. Because if I'm seeing it here at the OS level, it's probably in the 60 to 70 millisecond range. As you see, it's coming from either DAVG and KAVG, which is device, means I have a firmware issue of some sort with that HBA, or in this case, actually, it's a queue length of 32, my load, how many commands are writing to it, and you see I'm using 100% of my queue length. My queuing is my problem. So what happens is I'm sending commands faster, the queues are saturated, it can't get to the storage, so it starts backing up, and it backs up farther, and it backs up into the HBA level and into the host, and then keeps going into the guest. And it just keeps backing up. In this case, go in there, change your queue depth. This was, I'd probably go to 256 on this puppy, solve the problem. This is how you troubleshoot this stuff. And so when you're looking at those numbers for your queue lengths and seeing how much you're really using, have them try to say that the DBAs do a sample workload, using like a trace replay or this hammer DB kind of stuff. I prefer actual workloads, not synthetic workloads, i.e. hammer DB works great. That's nice. It's not real life for what your applications are doing, so you need to use a real life copy of your workloads if you can to get you the numbers right. All right, memory. We're going to talk through balloon driver, blah, blah, blah. So VMware memory. So SQL Server uses lots and lots of memory. Buy hosts with as much memory as you can. If you don't think so you can fill, if you think you have enough, you probably don't. You're going to run out of it because you're going to run out of RAM way before you run out of your CPUs. And of course, SQL Server is licensed by CPU, not by memory. And if it's licensed by memory, well, wait, we remember how that went with VMware. So also, VMware has an active memory counter. It lies. Actually, it doesn't lie. It's just incorrect. Their algorithm is something interesting. So when people are looking at their SQL servers, SQL Server's got 96 gig of memory in it. The VMware admin looks at it and goes, but you only have 14 gig of active memory. SQL Server's using all 96 gig. Trust me. VMware's counter is wrong. Ignore it. This is the only place where VMware numbers are basically just not valid. So balloon drivers. You need to have balloon drivers on. Things you got to worry about is in SQL Server, there's a feature called lock pages in memory. What this does, it allows SQL Server to control memory so the OS can't override it because I've decided that SQL Server is more important than my OS operations. When a balloon event happens, basically VMware goes to a lot of times it goes to the biggest OS. Actually, it goes to basically broadcast to all the OSs, hey, I need to reclaim memory. And of course, the SQL Server with active memory gets responded to, oh, you have extra memory. You can give me some memory. So the OS gets the command from VMware. The balloon driver starts to inflate. So the the OS, Windows in this case, has to go figure out what to do. It goes to SQL Server. You using the most, give me some back. SQL Server goes, I have locked pages. I get to say, you don't get it back. The OS, being the nice guy that the OS is, goes, oh, VMware will still here start using mine and keeps giving more and more of the OS's memory until you get a blue screen. Or if you don't have locked pages in memory turned on, what happens is when I do a ballooning happens, the memory is being reclaimed by the OS, SQL Server spools it out. If it's spooling out so fast at certain times, what it does, it's faster for me to just start over, and it does what I call a buffer pool dump. That means everything it keeps in memory, i.e. a customer table, so it's fast to look up next time, it goes out to disk. And then the next query, the next user goes, okay, look at my account. It has to go back to different part of disk and go read into memory that customer's I name. And normally you keep that thing in memory all the time, so you usually have sub-second response time to the application. Now you've got multi-second response time, and you're not meeting performance SLAs. Yeah, I think, the last thing on here too is when the when the balloon driver inflates, sometimes it never deflates until you reboot. That's one of those tricky ones that people don't realize. So NUMA, I have a session on NUMA, and I'm speaking with Rob, and Rob's in my audience here looking at me. So, but I do a full session, a full long, hour-long discussion just about vNUMA and SQL servers. There's a lot to cover. I'm trying to cover just the highlights enough to make sure you know what's going on. That is something really important. So NUMA, it's not just a CPU thing. In this case, we're talking memory. So if you happen to have a VM that is using more memory than it is inside your NUMA node, you're going to be spanning NUMA nodes. When you span NUMA nodes, you're going to have some performance issues if you are pushing CPUs. Best performance will always occur if I can fit my CPU counts and my memory count into the size of a single NUMA node. Obviously, big workloads, that's not going to happen, and we're going to have to span. And there's a whole bunch of different things with that. So know your boundaries. So Mark Amashuk, or I call him Mark A like everybody else because I could murder his last name usually, has a great blog post on how to size your things and how to know. So read this blog post. Or if you want a lot more information, come on Wednesday at 2:30. All right, overcommitment of memory. So repeat after me. We will not overcommit memory on SQL servers. All right, come on. We will not overcommit memory on SQL servers. We will not overcommit memory on SQL servers. If you have questions, rule number 1, go back there. It is possibly the most impactful thing you can do in a virtual environment is overcommitting your memory on a SQL server. Because everything's going to disk, your performance for the application is just horrific. You're trashing things. It just doesn't work. So at the end of the day, if you actually truly care about your performance, anything what you call tier 1, and for me, tier 1 should be less than 5%, in most cases 2% of your systems should be tier 1. Those need to have reservations to get you proper performance. And you're doing it, I know it's a pain in the butt and it causes all kinds of issues, and we'll talk about this a little bit later on. But that's the only way you can guarantee performance. And if this is really critical, really important, you go through all the issues and deal with it. How I like to define some things with this, so tier 1 for me, I'd say tongue-in-cheek to a lot of people. I only call it tier 1 when someone can look me in the eye and tell me what an hour of downtime costs. Because someone cared enough to go figure that out. At Cox, I used to work at Cox Communications, we had an application, an hour of downtime cost our company over $100,000. We knew that because we figured it out, because how much we cost from a customer goodwill, lost employer productivity, lost revenue, all that stuff was all figured into this massive calculation thing. So basically someone from the business side spent probably 3 or 4 days doing the full math to go figure that out. That means it's important. Someone actually cares about it. When someone says we don't know what the cost of downtime is it really that tier 1? I don't know, because no one else seems to care enough about it. And of course, we make sure you leave memory for VMware. Memory compression, or TPS, transparent page sharing, used to be on by default. They found some funny security hole, which to me isn't really a security hole, because if you actually read through all that, it is a contrived scenario that is impossible to happen in the wild. It can only happen in a certain lab under certain circumstances. But since then, though, VMware changed to secure by default. A lot of people think that means they turned off transparent page sharing. No, they still left it on, but it's now inside of a single VM. So if I have OS pages or if I have 0 data pages from things being read, they'll still be compressed in memory. I won't be able to span multiple VMs and look at it that way. You can turn the flag on, but at the end of the day, from a SQL Server perspective, it doesn't matter because A, we're not overcommitted memory, and you're not going to have the problem. And there's also very little gain from it because you're only decompressing or you're compressing your OS pages. Very rarely you'll see a database page. vMotion. So large SQL servers have problems with vMotion. They works great, rarely fails. What the problem is, especially if you happen to have a slow vMotion network, i.e., I have a customer, they've got a 1 terabyte VM, and they've got a 1 gig vMotion network. Do you know how long that takes to copy over? Oh, by the way, the rate of change on the 10 gig side of it, because that's where the application connects into it, is faster than 1 gig. So the memory data never gets up. When it is, so VMware, and Hyper-V does the same thing, by the way, it will eventually slow down the CPU to slow down that VM enough so the rate of change is slow enough the vMotion network can now finish the copy. It takes it 3 to 5 passes because it does the snap, the delta, copies it over, and loops through that. But eventually it gets there. No one ever talks about this one. And it's really annoying because everyone goes, why did the thing get slow for 30 minutes there? Because we were doing a vMotion. Did I go the right way? Whoops. Oh yeah, it was. Okay. Counters. Again, active memory counter is wrong. Don't use it. The only thing I look for basically is ballooning and swapping. As long as I'm not ballooning, I'm not swapping, my SQL server is going to perform fine from a memory perspective. Not having enough is the biggest problem you have. And asking for more all the time. And the DBA is going to ask for some outrageous numbers of memory, and it comes down to your application performance SLA. Because if I need sub-second performance for the application, I need to have the data in RAM, not on disk. So if I need to have a terabyte of stuff in the memory, I need to have it, or else I can't meet the performance. All right, CPU. Sizing. Buy the right hardware is the biggest thing I'm going to talk about here, but we're going to go through all these different sections. So in the past, we always bought the large, database administrators always went out and bought the largest thing the budget will allow them because we wanted to grow into it. So DBAs now need help in sizing because they've always had these massive servers, 30 cores, 40 cores, 80 cores, whatever, and they're only using 5% of it. But so they go, oh, I don't want to virtualize it because we need to go so many vCPUs. They need help understanding how much they're really using. Most of them don't understand or never had to basically shop for what I'm actually using today because the whole concept I can grow has always been foreign. Again, back to your performance SLAs. Do I have enough CPUs for this? I've taken machines, we've done physicals that were 80 cores, and we move it down to a 4 vCPU, and it runs still fine because they had that much extra overcommitment. The problem you got to run into, though, is maintenance. So database maintenance does take a long time. And if I'm not a 24/7 application, can I do my database maintenance and have it saturate my CPU all night long? That's perfectly fine. So the DBA wants to make sure, I had CPU problems from 3 a.m. to 6 a.m. Can we get more vCPUs? Was anyone using the application at the time? No. Why do you need extra CPUs? That's one thing the LEOs ask for. But granted, if it's, again, customers using it and saturating CPUs, definitely need to add more vCPUs. So right-sizing metrics. I like to tell people I want to keep my average between 25 and 40% with my maximums in the 70, 80%. It's kind of a guessing, but you're looking at your CPU utilization over time to figure out where you want to be and what it is. The thing to be careful, of course, is a lot of databases and SQL Server databases have periodic bursts, i.e. it's month close. We have all this month close processing. So we might drive our CPU really hot for 3 days around month close, and we're only at 5% the rest of the time. So if you do your right sizing metrics using either automated tools or doing it manually, you find, we right sized it, now it's way too small because we did it off of a daily workload, not the monthly workload. And also, power. I didn't want to create a new slide just for power. So basically, always run your VMware hosts in high performance. Never let them step down. SQL servers don't do a good job of cranking that back up. And there's still a lot of things that are serialized in a SQL server. So if my CPU goes from a 3.6 clock speed down to, say, a 3.2 or a 3.0 with a step down process, I'm actually taking that 20 to 30% hit of performance on that single threaded process. And they're still in there and they're still buried. So buying the right hardware. Chart here. So 4-socket box, but I got 10 cores that's running at 2 gigahertz. If I go spec in, look at the spec score on it, I got a 33.75. I'm paying $7K for a SQL Server license for that spec in score at 33.75. Or I can pay $7K for this one, it gets me an 82.75. So I can get over twice the performance off the same CPU by sizing it properly. Now, granted, this one here is only a 4-core box. So if I put 2 of them in there, I only get 8 total vCPUs. That might be too small. So you step up to, like this one here, which is an 2-socket, 8 cores, so it'd be a 16 vCPUs, and that kind of stuff. So, and most SQL servers will fit in that. When you have really large ones still, you need to scale. You need to have the big ones. So if you actually have a SQL server that's using 32, 64 vCPUs, you're actually going to need bigger hardware. But buy the ones that have the most cache and the highest clock speed. So SQL Server licensing is probably getting close to being the most expensive thing in your data center nowadays, unless you have Oracle. It actually starts to make storage look cheap. I've got a customer that's got, they're running 40 core boxes and they've got like 30 or 40 of those. So at 40 cores, that's $7K, so it's $280,000 per server, and they got 40 of those. That makes their storage system look cheap now, because we're talking multiple millions of dollars, tens and twenties and millions of dollars. So consolidate as far as you can, but you're not going to sacrifice performance. And that's the fun, tricky part, is what that knob is. How far you want to turn it this way, turn it that way, to get the most performance you can without doing things. So it comes down to overcommitment in CPUs. If you're conservative, don't overcommit for CPUs either. So basically, and this is a physical to vCPU, not a logical. So when you have hyper-threading, should still be turned on, but don't count it as your number of cores for consolidation rates. So in other words, if I have 16 cores in that box, do not, if you want to be conservative, only YAL 16 vCPUs. We have a lot of customers who do over-commit CPU, and it works fine. Again, goes back to your performance criteria on your SLA. We rarely find anybody going above 2.5 and being happy. A lot of people do around about 2. 1.5 to 2 is a fairly common number. So you can overcommit your CPUs. But then again, most people run out of memory way before they can do that. Counters. Ones I looked at the most, usage and percentage. I look at the from the host level and the VM level. I want to make sure those are right, where they're at, so am I sizing things properly. And then CPU ready and CPU co-stop. CPU ready is basically the amount of time that the VM was ready to run but had to wait for the scheduler to allow it to run. And I consider 2.5% as the threshold for performance issues. If it's greater than 2.5%, your odds are you're going to see it in the application, you're going to notice it. If you go to refine at 30 and 40%, you have major issues. CPU co-stop. This is actually one of the ones that people don't talk much about. It's actually a delay due to the scheduler. So you have 8 threads running, 4 of them ran one cycle, 3 of them ran the next cycle, and now the 4, they start to go back again, but now we have to wait for that last one to get finished. It stops the other 7 threads to wait for the last one to get finished and get caught up. It usually means that you have a lot of contention in the scheduler. I rarely see it by itself. I always see it along with CPU ready issues, but when you do see it, it's one of those, it's very impactful because it actually stops that thread from finishing. So you actually have a query that just doesn't finish, for a few extra microseconds or milliseconds. Also, when you're looking at it, look at the percents. So when you look at VMware's performance charts, it has it in numbers and time slices, so you have to go figure that out. So real time, it's 20 seconds, so I've got 20,000 milliseconds, and my CPU ready number is greater than 300, it's 2.5%. If I go to full day, it's full week, it's 45,000 for a CPU ready number, and you have to do all that math. First, as you're looking at ESX top, you can actually see the numbers directly. It is a core-based number, like here for, CPU ready, 23.9%. Very, very bad. But that's a summation of all the cores. Not a single core here is greater than 0.5. So this is actually working just fine. So make sure you look at it per core level, not at the CPU level or server level. So EVC mode. VMware and I just actually split on this one. I'm a big fan of, since my SQL servers are so expensive and I want to get the most performance out of it, I want to rotate that hardware much faster. In other words, you have a cluster, you have say 6 or 7 different VMware clusters, you're doing a hardware refresh on one of those every year. The SQL Server one, if you have a dedicated SQL Server cluster, should be the one getting that every year, and you move vMotion everything over, and you take those old hosts and give it to the person who just bought them. You give them 1-year-old hardware. That way I'm going to be able to get the most out of my SQL Server licensing. It takes a little bit of extra work, and to make it work properly, you have to have EVC mode enabled. So VMware will tell you in most cases that when you have a homogeneous cluster, leave EVC mode off because it might mask a bit set that you might be aware of or not be using. In my model, you have to have EVC mode on to make sure you can do the shuffling. And then, of course, after you've finished your shuffling and you need to raise your EVC mode, you need to take the outage to do the EVC mode upgrade, which you can time with your patching because we're still talking Windows servers. You're rebooting them month to month anyways. So make sure you time them together. So the other thing is, so EVC mode is very important because if you use Nehalem versus Westmere, so we're talking going back 6-7 years now, they added AES compression into the binaries inside of the source code, the machine level code basically. It gave you a 40% improvement on most encryption issues, all your SSL certs, all that kind of stuff, which was a massive leap forward. What other ones are out there, I don't know. I haven't found anybody who's published any results on it, and I don't have a lab big enough that lets me do testing to go see if any new instruction sets. Reading through all of them and talking to multiple different hardware people, they tell me there's probably very little from a SQL Server perspective that's impacted, but it's possible. And until someone actually can do the testing, we won't know. And the fun part about testing, you have to test multiple facets. You're going to do encryption, OLTP, ETL workloads, all those kind of things to see if it works properly. If you have a lab, you let me play with it for a while, I would love to go test all this out. NUMA sizing. So back in, we already talked about NUMA a little bit. This is from the CPU perspective. We're going to talk about NUMA. So pre 6.5, you needed to match the underlying hardware. So you need to have, if it's a 2-socket box, you can do 2 sockets, X amount of cores per socket, or you did 1 core per socket with many sockets, and VMware would automatically size it for you. So basically, if you happen to have a 16 vCPU machine, and it's on a 2-socket box, it would automatically create 2 NUMA nodes at 8 each. Or you went 2 by 8. Or you would basically went 16 by 1. So, but it caused lots of confusion. So also, if your cluster is heterogeneous, you will have NUMA issues, meaning if you happen to have 8 core processors, 10 core processors, 12 core processors, all inside the same EXXI cluster or VMware cluster, you're going to have some interesting issues as you vMotion VMs around. So if you do, though, make sure you have these 2 settings on, which is, NUMA.AutoSize equals true and NUMA AutoSize once equals false. And these are VMware advanced settings, so you got to power the VM off and go into settings, advanced settings, and then go add these in there because they're not there by default. What this does means every time you reboot your VM, not power, you need a power cycle, not reboot. When you do a full power cycle of the virtual machine, it will recalculate the NUMA capacity to determine is it set it right. In 6.5, they changed how this works, and now it's going to auto-calculate for you on first boot, and it's going to stay that way. So if you make changes again, you're going to have to reboot. You're going to have to basically change the number of cores in it. In most cases, VMware does the right answer for you. It takes care of it. On edge cases, you have performance benefits, but you need to understand the impacts, and you actually, to make it work properly, you need to be able to test your actual workload. Not a synthetic workload, your actual workloads. Because I can make any synthetic workload work and prove both sides are right. But your actual workload, there's only one answer, and you have to test it. If you don't have a way to test in your application through performance testing, you're not going to be able to do anything with edge cases. You're going to have to go with the defaults and let VMware manage it for you. Again, Oceanside, 2:30 Wednesday. Session more about in-depth on NUMA. Network. So I don't talk much about network overall. The biggest things I care about is jumbo frames. I like to see LACP enabled if possible. So especially if I'm using storage, with that, so I actually can do proper multi-pathing with my storage and guest type things, my iSCSI. Also multiple controllers, multiple NICs basically. So again, as I mentioned earlier, this vMotion needs to be fast as well, and how fast and how robust. Jumbo frames does matter. It does make a performance improvement. It doesn't make it go faster, actually. It just has less overhead, so more data will transmit over the same period of time. So HA and admission control. So HA should be enabled, obviously. Admission control should be enabled. So you be careful, though, about your FCIs and your availability groups and the restart rules. Why I talk about that is I got to make sure that when the failover happens properly before, from the SQL Server side before VMware does that. And also, you can have in the cluster settings from a Windows clustering service auto failback. So it fails over during an HA event, and then all of a sudden it starts back up, and it fails back as soon as it reports it's up. And you don't want a second outage of that, or it's a little blip again. So you be careful mixing that. So mission control should be enabled. One thing I worry about, though, is back when we talked about having, for tier 1 workloads, having a full memory reservation. Your HA slot sizes are now astronomically small, or tiny, and you have all kinds of skew problems. So you happen to have a host that's got 1.5 terabytes of RAM in it. You've got a VM with 512 gig in it. You have a hardware failure on that host. It needs to go find a place to start up, and since you have a reservation set, it needs 512 gig of free memory somewhere to find it. Odds are you don't have a host set up with that much memory unless you've adjusted your mission control rules to have 1/3 memory available, which is most people don't do that. So when you start having really large VMs that have your full reservations, you end up talking a lot about specifying a host for failover. So in other words, you have 12 hosts in your cluster, you have one of them set aside just for the failover. It's not doing anything at all. Licensing note about that, you can not license that as long as you only use it for HA purposes. If you use it for management, or i.e. I'm going to do BIOS updates on my other hosts and do vMotions of all of them, or basically go to maintenance mode, you have to license it, because the licensing rules are it has to all move at the same time, i.e. you have a hardware failure, boom, they all move at the same time. If you do maintenance mode, they're copying over one at a time. Most people end up licensing it just because they don't have to worry about figuring that out, or go, oops, we made a mistake and now we owe 200 grand. HA. So one thing at House of Brick we talk a lot about, I like to push the technology to the lowest layer in the stack. I don't like extra complexity. I'm a big fan of KISS, keeping it simple. So SQL Server has all these great features for built-in HA. When you're physical, you have to have them. You need to have your FCIs, your availability groups. When you're virtual, if you don't have an SLA that needs it, don't add complexity to your workload. I find very few DBAs who understand Kerberos authentication. Windows Clustering Services relies on Kerberos authentication for it to work properly. When you set it up, it works fine, but now it's broken, how you troubleshoot it. So now you gotta get the AD guy over there, and the Windows admin there, and you're all going, what's going wrong? You don't understand it. Guess what? If I remove that piece of complexity from my workload, it's going away. Not to mention, it's faster at the end of the day. You actually can go faster with a standalone SQL Server than you can with an FCI or an AG. There are some latencies from that. On the FCI side, not so much. On the AG, there's a few. So in the day, so a SQL Server HA will fail over basically in 30 seconds. VMware HA, it fails over in about 3 minutes. So if I can handle a 2.5 minute longer outage window on a hardware failure, I can simplify my environment. The DBAs will tend to fight this a lot, but you work through them. Think about what really is their SLA for that, and can they handle it. One thing, though, is SQL Server HA solutions allow you to do rolling patching, which is really nice. So I patch the passive node, I fail over, I patch the active node. It makes their life much easier versus if I'm in a standalone, I'm now taking an outage due patching, and can my SLAs meet that? And that's probably the biggest pushback you get. But at the end of the day, from an HA perspective, VMware HA is an awesome thing and solves a lot of that, and it simplifies the DBA's work. And actually, you can cut off 10, 20, 30% of their workload because they're not having to patch more servers, and all the complexity is gone. So DRS. If you have a large enough environment and you actually have a dedicated SQL Server cluster, I like DRS turned off. Some people get scared by that. VMware will tell you, no, you need to have it on. Why I want it off is I don't want large SQL servers moving around willy-nilly. If I can't turn it off, I do want for the most conservative method, especially in the newer versions now when VMware succumbed to marketing pressure and now balances their workloads all the time instead of only balance when there's contention issues, because they wanted to compete because someone else kept saying, well, we keep our workloads balanced, VMware doesn't. But it wasn't an issue. It's just a marketing thing. But now VMware succumbed and now does balancing in the newer versions, which annoys me. So I don't want my SQL servers to move. We talked about vMotion and how it slows down. I see it so often that a vMotion slows down my big SQL servers. And then DPM, I tend to find that you're working off in most cases because you have the vMotion issue. And of course, if you need DPM, then you turn it back on. All right. Failover cluster instances and availability groups. You need to have anti-infinity rules in place. They cannot run on the same host. Very, very, very important. The failover cluster instances still require an RDM-Ps. We already covered this. As I said in the last slide too, but basically only use SQL Server native HIDR when you need to meet your SLAs. And think about things from crash consistent versus application consistent from how you're doing your DR. SQL Server does a great job of working with any DR system out there. You can work with SRM, Zerto, Veeam, whatever, any storage-based snapshot process you want to go do. They all work fine. That's really cool. So just make sure you understand the difference between application consistent and crash consistent. So application consistent, crash consistent. Talk about snapshots from VMware's level and storage level. Do a session about that later on today, later on Wednesday as well. Short version is with snapshots, application level snapshot is the same as a backup. It does require the Windows to use VSS. Can do when you use requires the quiesce, and the quiesce can cause an I/O pause in the application. It will vary by configuration. I've seen it configured incorrectly and taken over a minute to do a pause, but in some cases it should be between 1 and 3 seconds. And is that okay for your application or not? Crash consistent is no different than basically if I went behind the server and unplugged it and it went down, and how fast it comes up. And SQL Server has to go through a redo and undo process to make sure it's clean. And the length of time that takes will depend upon a lot of things inside the SQL Server, but in general, it adds a few seconds to the reboot. If you have gobs of TempDB or hundreds or thousands of databases, it can be much longer. At the end of the day, business rules determine which one you want to be using or need to be using. And the other thing is your storage system. Storage groups, you need to have a thing called consistency groups. It varies by storage vendor what they call it. Some don't offer it even. What it means basically is when they do the snapshot at the storage level, what gets snapped? Because your data and your log files need to be snapped at the exact same instant. Not snap, snap. No, it has to be the same. Because if you just snapped one, then snapped the other one, they're on different data stores, and they didn't happen instantaneously, your database will come up and show corrupted. You can fix it, but it'll take you probably an hour or 2 hours. You just introduce an hour of downtime because you did not snap at the same time. If you can't snap at the same time, then you must put all the drives on the same data store and do the full snap on the one data store. Which if you have really large VMs that have high performance and you're using multiple data stores, you got to decide, is my storage snaps going to be more important or my performance going to be more important? SQL Server, end of the day, follow all the best practices for SQL Server. There's very few things that change because there's no things that really change because you're now a virtual machine. And as we went through all the things here, there's as many, if not more, best practices in SQL Server that can make 30 to 40% improvements of just from default settings that SQL Server comes shipped with. Don't put dumb things on your servers. I see so many people have way too many agents. And then monitoring. I had a customer that had, basically they had a network agent for monitoring the network. They had an OS one monitoring all the OS. Oh, it collected SQL Server counters too. They had a SQL Server agent, and then they had an IDS, an AV, and something else. 80% of the processing power of that server was used for those agents and not for SQL Server. Either over-monitoring and over-analyzing the system. AV is still required. A lot of people turn SQL servers off, AV off for some reason. I don't know why. It's very important to leave it on. There's a KB that walks through all the different fun stuff, from Microsoft, which I should have linked, but I will update my slide deck pretty soon. And of course, for me, I am talking to a lot of people about basically starting more robust, secure networks. Your NSX type technologies, where I'm having less and less things for intrusion, because your database is a source of hacking. That is one of the things they want, because when you hear all these things in the news about someone get compromised, it's the database that get compromised. Not two people are just sniffing out credit card transactions over the wire. That happens, but most of the time it's stored in the database and they're pulling off from the database. More security around your SQL servers is always, always important. SQL Server on Linux, just mention this overall because it's coming up. No impacts from being it virtual. It's awesome. House of Brick, we're starting a blog post series here pretty soon. Basically, once they release it, it's not out yet, to talk about all the different performance tweaks. So basically, all your Linux tweaks that you do for other performance things in Linux will work for SQL Server and make it better. Monitor and baseline. Ask your DBAs to show them their baselines. Because what happens is you get these fights about, oh, it's running slow. Well, the network's slow. No, it's storage. No, it's virtualization. No, it's SQL Server. Who's at fault here? You know what? If you have baselines, you can pull things up and figure it out fairly quickly. If there's no baselines, it's really hard because define slow. From the application SLA we talked about, hey, it takes 3 seconds to load a page. We agreed it's supposed to take 1 second. Now we need to figure out where it's at. Look at my baselines. Have the DBA show them baselines to you. You show your baselines to them, so you can look at the storage ones. Give the DBAs access to these things. DBA should have access to vCenter. And at first, they'll have a lot of questions about it, and they'll ask you and bug you. But eventually, they'll learn it. They'll stop bothering you. And when they have an issue, they'll just go, oh, hey, there's an issue. Go fix it. All right, so from the perspective of the DBAs, this is one of the ones I stole off the internet. I like the little matrix one about they think that that's what they're doing. They're not. They're just staying up late at night trying to fix code. So care and feed the DBAs, already mentioned, vCenter access. Give them access to your storage things, your web tools, your VROPs, whatever you have, and then partner with them. At the end of the day, you all have the same business critical stuff, business goals you're trying to accomplish. Get together and figure out how you accomplish them together. And that's all I have. Questions? Yes? Pardon? Oh, COTP cost threats for parallelism? Okay, so the question is, what about the COTP and max stop settings for SQL Server? Max stop should equal your NUMA node. If not, half of the size of what you have in it. So if you're a single NUMA node, I tend to put it for about half. Cost threshold, I put it between 25 and 50. Depends, or I run a query to determine what my parallelism amounts are. And there's actually good queries online you can go find that will show you how much the system's going to split. VMDKs are massive mount points. We define mount points. You mean like an NFS mount point? Uh-huh. Right, but they're all in a VMDK still, aren't they?
Yeah.
Okay.
But from a management perspective, it's nuts.
Yeah. You.
We're trying to put them to six or VMDKs rather than
But does it really matter? I mean, I'm trying to figure out how's it more difficult for you?
when I'm hitting VMDK limits on the ends, and they're keep requesting more mount.
Oh, so basically you're saying you'll have a multiple view. So, okay, now I see. Yeah. Right, and so in the day you've got a data store that's going to be, 14 terabytes, whatever, because it limits, yeah. Yeah. Yeah, I agree with you on that. I would go back to SLAs on recovery, because if we happen to have a storage glitch, what happens? And how fast we're going to do restore from whatever processes and stuff. And so I tend to like things less than 2 terabytes because of my recovery intervals. It just varies by that. 1984.
Do you have any opinion on native iSCSI?
The question is, do I have an opinion on native iSCSI? Yes, I like native iSCSI. It works just fine. It works great for clustering. It depends upon but don't forget, when you're using ingest rules, you lose obviously a lot of VMware features from a storage vMotion perspective, and you just got to handle that. But it does fail over just fine, and I have no problems with it. Yeah, 10 gig jumbo frames. Or 10 gig or faster or jumbo frames.